Protons and neutrons have a mass of 1 atomic mass unit, whereas electrons have no mass. But this week, we're going to focus on electrical charge. Electrical charge can be positive, negative, or neutral, and it can be big or small, or it can be 0. So protons have a charge of +1. Neutrons are neutral. They have 0 charge. Electrons have a charge of -1. This is something you should already know for Unit 2. All right, so here's a beryllium atom, okay? And one thing we've talked about is the total charge on an atom, okay? The total charge can also be called the net charge. In this unit, we'll use the term net charge a lot. It just means the total charge. So 4 protons in the nucleus, 5 neutrons, which are neutral, and 4 electrons. Remember, for atoms, the number of protons always equals the number of electrons. So the net charge of any atom is always 0 because the number of protons equals the number of electrons. You might be asked about the nuclear charge. That's just the stuff in the nucleus. So what's the nucleus? What's the nuclear charge of this beryllium atom? It'd be +4 because the neutrons don't count. Neutrons are neutral. They have no charge. Protons have a +1 charge each. 4 of them makes a +4 charge. Okay, another thing you need to know for this unit, Unit 3, is something from Unit 2. The noble gases, we call them the noble gases, the elements that are in group 18, because they have 8 valence electrons, and we say that that means they have a full outer shell. Or a new phrase that you'll hear me use is they have a stable octet, okay? Octet means 8 valence electrons, like an octopus has 8 arms. Octet means 8 of something. They are very stable and totally content. We call them the noble gases because they will not bond or react with any other elements, just like kings and queens don't want to have anything to do with the common people. The noble gases will not have anything to do with any other elements. They will not bond or react because they're so happy and stable. 8 is great is a way to remember that 8 valence electrons is the perfect amount for a stable atom. Okay, so what is the net charge of this beryllium atom? Do you remember? What is the net charge, meaning the total charge of this beryllium atom that you just saw a moment ago? You should remember it's 0 because an atom has a net charge of 0 because the protons equal the electrons. All right, now we're going to do something. We're going to mess around with the number of electrons. Okay, so let's add 1 electron. See that? We added 1 electron. Now here's the question. What is the net charge of this beryllium ion? If something has a different number of electrons than the original atom, we call it an ion. Ions are charged particles. They're either going to be a positive charge or a negative charge, not a 0, like an atom. We added 1 electron. You should be able to figure out that it has a total charge or a net charge of -1 because we've got +4 from the protons. Now we've got -5 from the electrons. And if you do your integer math, that adds up to -1. We just added 1 electron. That gives it a -1 charge because it was 0 before. All right, now what happens if we add 2 electrons? Look, here I've added a second electron. Here's the question. What is the net charge of this beryllium ion? Remember, an ion is our name for a charged particle that's not 0 anymore. Okay, we added 2 electrons. The answer is going to be -2. Remember, as an atom, the charge was 0. If I add 1 electron, it becomes -1 charge. If I add 2 electrons, it becomes a -2 charge. Now what happens if I remove an electron? We're starting with the beryllium atom again. I'm going to remove 1 electron. See, I removed 1 electron. Now what's the net charge going to be of this beryllium ion? Think about it. Think about it. You should be able to figure out it will be a +1 charge because we have 4 protons. Now we only have 3 electrons. That adds up to +1. Or you could say, okay, well, I took away 1 of the electrons, so there are more positive things than negative things. The charge is going to be positive. It'll be a +1 because I took away 1 electron. Okay, so here is an atom. Okay, here's an atom. It's an oxygen atom. 2 electrons in the first shell, 6 in the second. You can see the electron configuration, or you can count it in the Bohr diagram right there. It turns out atoms really want to be like noble gases because noble gases are stable with the 8 is great electrons in their valence shell. Okay, so what can this atom do to become stable? It could gain 2 electrons. It could steal electrons from somewhere. Where does it steal them from? Some nearby atom that wants to get rid of electrons. Okay, there are always lots of atoms around and always lots of electrons around. Okay, so if it gains 2 electrons, now it's going to be like a noble gas, and it's going to feel really stable. Okay, but that means it has a different electron configuration. Now it's 2-8. Yeah, because it's like a noble gas. Okay, now we call this an oxygen ion, and we could write it this way. It's an oxygen with a -2 charge because it gained 2 electrons. So instead of having a 0 charge, it now has a -2 charge because it has 2 extra electrons, and it's more stable. Atoms will turn into ions to become more stable. Let's try this one. Here I have an atom of potassium. 2881 is its electron configuration. What's it going to do to become more stable? Okay, it wants to have its electrons be like a noble gas. It doesn't want to turn into a noble gas, but it wants its electrons to become like a noble gas. So it's going to kick out 1 electron. Okay, now it's much more stable. If it kicks out 1 electron, the electron configuration will be 288. And now we call it a potassium ion instead of an atom. And because it lost 1 electron, it now has a +1 charge. Because it has more protons than electrons, it lost an electron. If you lose electrons, the charge becomes positive. That may seem a little brain bending. Don't worry, we'll talk about it more in class. One more new idea. Atoms are lazy. To become like a noble gas, they will move, meaning they will lose or they will gain, they will move the fewest electrons to become like a noble gas. Let me show you some examples. Okay, here I've got sodium. It has a 281 electron configuration. It could either lose 1 electron or gain 7 to become like a noble gas. It could kick out that 1 electron, or it could steal 7 electrons from somewhere. What's going to be easier? Remember, atoms are lazy. They want to move the fewest electrons to become like a noble gas. So what's easier? Losing 1 is easier than gaining 7. That's moving fewer electrons around. So sodium is going to kick out or lose 1 electron to become a 2-8 electron configuration. What about magnesium? Okay, it's 282. It could either lose 2 electrons or it could gain 6 to become like a noble gas. Yet 8 is great electron configuration in its valence shell. What's easier? Losing 2 is easier. We're moving fewer electrons. So magnesium is to become an ion is going to kick out 2 electrons. What about calcium? It's 2882. Well, it could either lose 2 or gain 6. What's easier? Losing 2 is easier. That makes it have an electron configuration of 288 when it loses those 2 electrons. What about something like sulfur? It's 286. Well, it could either kick out 6 electrons or it could steal 2 electrons from somewhere nearby. What's easier? What moves fewer electrons? It's going to gain 2, and now it'll have 288. What about chlorine? Will it lose 7 or will it gain 1? What's easier? Gaining 1 is easier than losing 7, so it will be 288. If the number of electrons is small, it will lose the electrons. If the number of electrons is large, the atom will gain some electrons or steal them from somewhere. Okay? So let's just try one or two more examples. How can this nitrogen atom become more stable? This is nitrogen. How can it become more stable? It has a 2-5 electron configuration. Okay, it's going to gain 3 electrons. That's easier than kicking out 5. Now it will become a nitrogen -3 ion. An N3- ion is more stable than an N atom. Okay? How can this chlorine atom become more stable? It has a 287 electron configuration. To become more stable, it wants to become like a noble gas. It wants to get 8 is great in its valence shell. Okay? To become more stable, it would steal an electron from somewhere. Now it will have a 288 electron configuration, and we will call it a chlorine ion or chloride ion. With nonmetals, the ending changes when you go from an atom to an ion. So chlorine becomes chloride. This is a chloride ion with a -1 charge because it gained 1 extra electron. Strontium. What is this strontium going to do to become more stable? It has a configuration of 2-8-18-8-2. What's it going to do to be more stable? What's the easiest, laziest thing to do? It's going to get rid of 2 valence electrons, and then the next shell down has 8, so now it's like a noble gas. And the strontium atom will now have a charge of +2 because it lost 2 electrons. Now it has more positive charges than negative charges, charges of +2. All right,